Good morning to one and all. Today we will discuss about the Mohr circle part 2. I myself Akash Mohanty from the School of Mechanical Engineering, VIT University, Vellore. To draw the Mohr circle, we have to follow the following points. The first point is that to draw the Mohr circle on a Cartesian coordinate system, the x-axis and y-axis are identified as sigma axis, that is normal stresses, and tau axis, that is for the shear stresses respectively. We have to choose the proper scale to convert the stress values into the suitable units for both the axes independently. The first 2 points of the circle to be plotted as point 1, that is sigma x tau xy, this is vertical plane VP, and the point 2 sigma y tau xy, this is horizontal plane HP. The line connecting these 2 points is the diameter of the circle and will intersect the x-axis. This intersection point is the center of the Mohr circle. Knowing this diameter and the center of the circle, the Mohr circle can now be drawn. The center of the circle is located where the diameter intersects the x-axis, that is sigma axis. It is also the average normal stress. So here in this Mohr circle, all the normal stresses are presented in x-axis and the shear stresses are in y-axis. Now the construction of this Mohr circle. Here we must remember that all the normal stresses are presented in x-axis and all the shear stresses are presented in y-axis. If the shear stress in any plane is in clockwise manner, that is we have dedicated plus y-axis. If the shear stresses are in anti-clockwise manner in any plane, that is horizontal and vertical plane, it is represented in minus y-axis. Similarly, the tensile stresses are presented in positive x-axis and all the compressive stresses are represented in negative x-axis. The construction of Mohr circle is as follows. First, we have to draw the cosine figure. In this cosine figure, the square is drawn and sigma x, sigma y is represented along vertical and horizontal plane, and the shear stresses are represented in both horizontal and vertical plane as tau xy. The oblique plane is presented as theta angle from the vertical plane measured in anti-clockwise direction. Now after drawing the cosine figure, we have to draw the Mohr circle. For this purpose, we have to draw the x-axis and the y-axis. Now the cross-section of x-axis and y-axis is the center of the coordinate system. Now we have to convert the sigma x into suitable scale, and since this is tensile is nature, so this is represented in positive x-axis and the shear stress in the vertical plane is tau xy. Try to rotate the block in anti-clockwise manner, so it is represented in negative y-axis. So now we are getting the vertical plane. Similarly, we have to represent the horizontal plane. In this horizontal plane, the normal stresses is sigma y is tensile in nature. So this is right side of the x-axis or positive x-axis, and this shear stress in the horizontal plane, try to rotate the block in clockwise manner. So it is represented positive y-axis. Now we got the horizontal plane as well as vertical plane. Now we have to join this horizontal plane and vertical plane by a straight line. The intersection point of these two lines is the center of this Mohr circle. By knowing the center of the Mohr circle and by knowing the diagonal, that is diameter h to hp to vp, we will draw the circle. This is called Mohr circle. Now we will represent the oblique plane. This oblique plane is at angle theta degree from the vertical plane. So here we will mark one point that the question figure which contains horizontal plane and vertical plane, they are 90 degree to each other. So in the Mohr circle, the angle between horizontal plane and vertical plane is 180 degree. That means if we will go from Mohr circle to the question figure, which is represented in left top corner, the angle is multiplied by 2, and in the other way, if we go from the question figure to Mohr circle, angle is multiplied by 2, and if we will go from the Mohr circle to the question figure, then the angle will be divided by 2, because here we can see the angle between horizontal and vertical plane is 180 degree, whereas in the question figure it is 90 degree. Now we have to represent the vertical the oblique plane. This oblique plane is at angle theta degree, measure anticlockwise direction. So from the vertical plane we will draw 2 theta angle, and after drawing this one 2 theta angle, this is for the oblique plane. We will join this point from the center of the Mohr circle to the periphery of this Mohr circle. So we will get one point on the Mohr circle. This point is a plane, that is called oblique plane, because every point on the Mohr circle is a plane. So now this oblique plane has two coordinates, one is in x-axis, one is in y-axis. So whenever we will measure this horizontal distance along x-axis, it will give the normal stress. So the normal stress in the oblique plane is sigma n, and the the magnitude is measured in the x-axis is normal stress, and the value of the oblique plane along y-axis is the shear stress in the oblique plane. By just measuring the value with the help of a scale and multiplying the suitable scale factor, we will directly get the normal stress and shear stress in the oblique plane. Now if we join the oblique plane with the center of the coordinate system in a scale, this is your resultant shear stress in the oblique plane. By measuring this distance and multiplying the suitable scale, we will get directly the resultant stress in the oblique plane. The angle between x-axis and the sigma r line, that will give you the value of angle of obliquity. Now by measuring directly this value, this angle, we will get the value of the angle of obliquity in the oblique plane. Now you will see this Mohr circle is intersecting the x-axis at 2 points. First point is the largest distance from the center of the coordinate system. This is sigma 1 value, that is major principal stress, because in this point, which is located in the Mohr circle, is a plane where the shear stress is 0. So this is major principal plane. The stress normal to this plane is major principal stress. Similarly, the circle is intersecting the x-axis in another point where the magnitude is minimum. This plane is called minor principal plane, and the stress which is normal to this plane is minor principal stress. Now the maximum values for the shear stress is happening in two diagonally opposite plane. The first plane is called major shear stress, and the value is tau max. Similarly, in the other point, which is diagonally opposite, is the minimum shear stress plane. The magnitude is tau min. The value from the center of the Mohr circle to the center of the coordinate system is sigma average. So here we will see the angle between vertical plane and the plane of major principal plane are measured as 2 theta pp. So if you want to locate this plane in the question figure, so from the vertical plane we have to take the value of theta pp, that is from the vertical plane to the plane of major principal plane. We have, whatever the value will be there, we have to divide it by the 2 and represent in the question figure. Similarly, the angle between major principal plane and plane of maximum shear are 90 degree. So in the question figure we will represent the plane of maximum shear as 45 degree. So this is the way we will draw the Mohr circle for a given question figure, where the normal stresses and shear stresses are both acting in the vertical and horizontal plane. So this figure shows the angle between the major principal plane and plane of maximum shear are 90 degree. Now in the question figure it will be 45 degree. The direct stresses with simple shear finally looks in like this figure. Thank you.